Good evening, sir.
Good evening, sir.
Good evening, sir.
Good evening, Rohit. So today we'll do physics, alright?
Yes, sir.
So बताओ हाँ? लड़की है ना वो?
लड़की लड़की है नाम भी लड़की के ही है
अमिता खतोड़े
हाँ ये हाँ के
वो छोट बहन है छोट बहन या हेलो
Good evening, sir.
yeah good evening so let's see here we are doing gravitation. In gravitation today we'll do mass and weight, the difference between mass and weight. Gravitation. See what we mean by mass. The mass of a body, it means it is, say mass, it is the content of matter, of a body. The amount of matter contained in a body is called as its mass. The amount of matter that is contained in the body that we call as the mass. So definitely it depends on the number of atoms, the number of molecules of which it consists of. Alright. So depending on the number of atoms or the number of molecules it consists of, we know its mass. The mass is defined to be in kilograms. Its SI unit is kilogram. SI unit is kilogram. Also, so we also call it to be the inertial mass of an object, and the inertial mass of an object can be measured by the formula of force. Right? The second thing which we are looking is weight of an object. Very good, Sampath. The weight of an object. The weight of an object, it is the force with which gravity pulls an object. So see, both are two different things, mass and weight. However, in our regular life, we use mass and weight to be synonymous to each other. Okay, but in reality, the mass and weight, they are two different terms. One of them is the content of matter, that how much matter, how many atoms, how
Okay.
many molecules are present over there. Whereas weight, it is the force. So, of course, we know the difference between force and mass. So, weight, it is the force with which gravity pulls an object. Yes,
Sir, so in questions, if they give force, we can even take it as weight.
we can take it. Which one?
Sir, if in questions we are having force, then we can take it as even weight, no, sir, same value.
Okay, we'll see how to convert mass to weight. Yes, we'll see how to convert when some mass is given,
So,
then how
sir,
do we convert it to weight?
sir, I
Yeah.
have a doubt that
Sir,
the
but sir,
value of force will be same as the value of weight, no, sir.
sir,
Mm-hmm.
another definition of weight is it is a force which is attracted towards the center of the earth.
Yeah, the force with which all the objects are attracted towards the center of Earth.
Sir,
It
its
is the
SI
weight.
unit is Newton.
Yeah, since it is a force, its SI unit will be Newton.
Newton.
All right. Okay. Okay. Sampath.
Yes,
Sampath.
sir.
Okay. I just want to come to you again.
Okay.
What you want? I didn't get your point.
Sir, sir, I was saying that if in questions we have the value of force, then we
Mm.
can take the value as even the same value for weight, no, sir.
No, see, if you are given some value of force, you can't take it as weight. Okay. As a force can be due to any agency. If that force is due to the gravity, then only we can call it as weight. Okay. The force that is there, it should be due to gravity, then only we call it as weight. If the force is made applied by something, then we can't call it as weight.
Okay, sir.
Okay. So what is weight? It is the force with which gravity pulls an object, or we can also say it, or we can apply the definition for it. We can say that weight is the force with which all the objects, the force with which all the objects are attracted towards the earth. So the force with which all the objects are attracted towards the earth, that we call as the weight. So weight, it is the force with which all the objects are attracted towards the earth or towards the center of the earth. You can also say weight to be the force with which gravity pulls an object. So let us see then how do we find out the weight of an object. So consider any object to be lying on the surface of the earth. So let's say this is the surface of the earth. However, even if the surface is a sphere, we are taking a portion of the sphere. So here we have any object. Okay, we have an object lying over here. Let's say the mass of the object is m. So when I say its mass is m, so mass equals to m. It means its mass will remain the same, whether it be earth, whether it be moon, whether it be the space. Okay, the content of matter, the number of atoms which are present in that, they will remain the same. It won't change. Okay. So the mass of this body, it remains the same. Whereas, say it's a force. So the gravity is attracting this body towards the center of the earth. So the gravity attracts this body towards the center of the earth. And this force of gravity, this force of gravity with which the object is attracted towards the center of the earth, this force of gravity is equal to mg. We call it. And why we call it mg? or why we call it as this. So weight will be equal to the force, which is equal to mg, as force is always equal to mass multiply acceleration. All right. So acceleration here, if acceleration is brought about due to gravity, and acceleration due to gravity is always equal to g. All right. So acceleration due to gravity is g, which is 9.8 meter per second square. On the surface of the earth, the value of acceleration due to gravity is 9.8 meter per second. So therefore, the weight of the body will be the same as the force.
Yes, sir. Sir, can I
Got it?
get one more?
Which one?
Sir, mass is like the value of mass is constant, but the value of weight keeps changing from place to place.
Yeah, the value of weight will change since the value of acceleration due to gravity changes from place to place. Okay, let us
So,
see how
like for
the
example, the weight of if our body like our weight on the earth is different and our weight on the moon is 1/6 our weight of the earth.
okay. Suppose you are in a lift, okay, and
Yes,
that
sir.
lift has a free fall. Suppose you are standing on in a lift on a weighing machine, okay, and the lift starts having a free fall. So in that case, your lift will show your zero weight. You won't have any weight in your body, but the content of matter would remain the same, or the amount
Yes,
of mass that your body has, it will remain the same. The amount of mass won't change. Got it?
got it, sir.
So yeah, the amount of mass will not change, and therefore only the weight changes. So weight is a
Sir,
variable. Yes,
okay. So then weight is a scalar quantity and mass is a vector quantity.
mass is a scalar quantity, weight is a
Sorry,
vector
mass is
quantity.
scalar, weight is vector, yeah.
So you can use this one also. You can say here that mass, it is a scalar quantity. I missed out this point. Thank you. So mass, it is a scalar quantity. That means it does not have any directions. So mass is a scalar quantity and weight is a vector quantity. So I can add weight.
Sir, can we write it as mass is constant throughout the universe, everywhere?
No. You can't say that mass is constant throughout the universe.
Why, sir?
However, it remains same everywhere. You can say mass remains same everywhere.
So can
Okay,
we
but you
write
can't say
as
that
mass is
why.
an fundamental quantity
Yeah, we can say mass is a fundamental quantity.
and weight is a derived quantity?
Yes, mass is a fundamental quantity and weight is a derived quantity. That is correct.
Sir, can
See,
you say
even mass also becomes a variable under relativistic conditions. So it is only under the relativistic condition that the mass becomes a variable. Otherwise, the mass is not a variable. So here, weight is the force with which all the objects are attracted towards the earth. It is a vector quantity and it is measured in Newton. The SI unit of the weight is Newton. Okay. Now let's try out a few questions. I will show you one question from NCRT. Okay, and you will be tricked off by that question.
Sir, it's
Let's see.
weight is mg, right?
Yeah, weight is mg. So let's see this NCRT question from gravitation. After mass and weight, we will have some more questions. We'll move on to thrust and pressure. After this, we'll start with thrust and pressure. So let's see this question from NCRT. Okay, see this question number 3, and you try to solve this. Try to solve the question 3. I'll show you a trick. Okay, so solve this. You are given, see the question. See, what is the magnitude of the gravitational force between the Earth and a 1 kilogram object on its surface? Mass of Earth is given to be 6 multiplied 10 to the power 24 kilogram, and radius of the Earth is given as 6.4 multiplied 10 to the power 6 meters.
Sir, we can do weight is 1 kg.
How can you say weight is 1 kg?
No, sorry, sir. 1 kg object on its surface. So weight is mass into gravity. So first we can do 6 into 10 to the power 24 into sir, we can do this, right?
Just read this question once. Everyone read this question. I'll ask you the answer. Read this question and think of the ways by which you can solve this. Question is not tough. It's easy. Okay. There are a number of methods for solving this.
Sir, we can do G is equal to capital G M by R square.
Yeah, what happened?
Sir, we can use small g is equal to capital G M by R square.
No.
Sir, but radius is also given, no?
Yeah, radius is also given. So that's what I'm saying. Take time. Take your time. Think of this possible solution. Okay. Okay. Shall I help you out? Is there anyone who require any help? आप थोड़ा सॉल्व कर देना सॉल्व करना हुआ all right, shall I help in solving this?
Sir, 1 minute.
Okay, take your time, take your time. Okay, can you just think of, can you use this formula? F equals to G M over R squared. Can you use this formula?
Yes, sir.
Okay. So try using this formula.
The value of capital G is 6.67 into 10 to the power minus 11, no?
Yeah, it's 6.67 into 10 to the power minus 11. Okay, if anyone gets the answer, then just inform. Okay, so see this. We will be able to.
Sir, is
Yes.
the answer 9.8 Newton?
Yeah, the answer is 9.8 Newton.
Okay, sir.
Okay, the question is very tricky. Tricky in the sense, if you don't get it, you will have to do long calculation and still you will get the same answer. So answer here that you will be getting F will be equal to 9.8 Newton. And this 9.88 Newton, how we obtained this? We obtained it as mass 1 kilogram multiplied by the acceleration, that is 9.8. Okay, so you get it mg, which is 9.8. See what the question asks you. It asks what is the magnitude of the gravitational force between the Earth and a 1 kilogram object on its surface. Okay, so the Earth attracts the object with the force, and that force we call as the weight. Okay, so definitely it will be equal to mass multiply acceleration, which you got like this. If you solve it like this, then also you get the same answer. See, you put the value of g, which is 6.67 multiplied 10 to the power minus 11, multiply mass of the earth, 6 multiplied 10 to the power 24, divided by radius square, which is 6.4 times 10 to the power 6, the square, multiplied with the small mass, which is 1 kilogram. So even if you solve this, okay, you will get the same value as 9.8. How? How we get this? If anyone remembers, we got the value of G as Gm over R squared. Is there anyone who remembers this formula? We got the value of acceleration due to gravity as Gm over R squared.
Yes, sir.
Okay, and we calculated this. So here we have this gm over r squared. So this we calculated. This value turns out to be 9.8. So definitely this is 9.8. So
Yes,
this
sir.
whole calculated. Just now you can perform the calculations and check. You'll get this as 9.8. Okay. So everyone is clear about the answer? Either you obtain it directly as F equals to mass times acceleration, which is mg. The mass is 1 multiplied g, which is 9.8. You get the answer is 9.8 Newton. Or you do these calculations and then you get it as 9.8. So that's another way of getting the same answer. Now it depends on your trick, on your understanding.
Where I
Yes.
got 9.77, so can I round it off to 9.8?
Yeah. Obviously, you can round it off.
So I got 9.8 meter per second square.
Yes.
Sorry, sir, Newton, 9.8 Newton. My bad.
Got it, everyone? Okay. So the next topic we discuss is
Sir,
thrust.
I had a doubt.
Yes.
Sir, when we multiply, we'll get 400.2 by 40.96, right?
Which one?
Sir, this one, when we multiply this.
Which one?
Sir, when we
So,
multiply 6 point, never mind, sir. I got it. Sir, can I send a picture of my answer to you on your WhatsApp? Then can you check?
currently, I will not be able to use WhatsApp right now.
Sir, after class, after class.
Okay. You may send it, so I'll check it after the class.
Yes, sir.
Okay, see. So next topic we are doing here, thrust.
Thrust
You
and
see
pressure.
what is thrust?
Sir, thrust is the force applied on an object.
Okay, let's see thrust.
Here, thrust
Okay,
is a
so
force acting normal to the surface.
yeah, so thrust, it is the force,
Perpendicular to the surface.
it is the force
Where that acts
acting
perpendicularly to no, sir.
Perpendicular to the surface.
perpendicular to a surface. The force acting perpendicular to a surface is called thrust. Okay. So what is thrust? It is the force acting
Acting
perpendicular
perpendicular to
to a
the
surface.
surface.
Yeah, what happened? So see, the forces that act perpendicular to a surface, they are called as the thrust. So we see different examples like this. Suppose you have an iron nail and you have an iron nail and you hammer on this iron nail. So if you hammer on this iron nail, if you start hammering on this iron nail, so you are applying a force which is perpendicular to the surface. So we can call this force to be thrust. If your force is not perpendicular to the surface, so that force will not be called as a thrust. Alright. Sometimes if you apply a force at a certain angle to the area, so only a part of the force will be acting as a thrust. Not all the force will act as a thrust. So in most of the cases, we get we try to use the maximum amount of force we are applying as it increases the effectiveness. If on the same nail, suppose I apply a force which is not perpendicular, let's say if I apply a force like this. I apply a force like this. Am I audible? Hello?
Yes, sir.
Yes, sir.
Yeah. Is it okay?
Yes, sir.
Is my voice level okay?
Yes, sir.
Okay.
Yes, sir.
So sometimes if we apply a force which is not perpendicular to the area, so the effectiveness of force will decrease. So you can assume that a part of our force is acting perpendicular to the surface and a part of it is acting parallel to the surface. Like in this case, if we consider the force acting in this direction, so I can assume this force to be made up of two parts, a part of the force acting perpendicular parallel and a part of the force which is acting perpendicular to
Perpendicular.
the right. So the amount of force or the part of the force which acts perpendicular to the surface, to only that force we call as the thrust. Got it?
Yes, sir.
The next quantity, okay, what will be the SI unit of thrust then?
Sir, Newton.
Yeah, SI unit of thrust would be Newton. Since it is a force, so its SI unit will be Newton. Okay. Now let's see what is pressure.
Sir, pressure is the force acting per unit area.
Pressure is the
Force acting on unit area.
no,
Here we can say thrust acting per unit area.
it's not the force. See, it is the thrust acting per unit area.
Unit area.
The
Sir, but
thrust,
isn't thrust and force same?
yeah,
Sir, isn't thrust and force similar?
no, they are similar but not the same. That's what we are saying here. Only the perpendicular part of the force is the thrust.
Yes.
Like here, when I applied the force like this in this direction, see, when I
It's
applied the force
perpendicular.
like this, I can see that amount of force will tend to move this nail towards the right. So this amount of force here is the horizontal part of the force. This amount of force here is the vertical part of the force. Only the vertical part of force which is acting perpendicular to the surface, this is the thrust. This force is not the thrust. Got it?
Got it,
So
sir.
the force that is acting perpendicular to the surface, that is thrust. And therefore pressure is defined as thrust acting per unit area.
Got it, sir.
So thrust acting per unit area is called as the force. It's called pressure.
Yes, sir. Sir, and its formula is P is F by A.
Its formula is,
P is F by A.
yeah, we write it. See,
Sir,
these are the,
first its SI unit is Pascal.
yeah, we write pressure to be equal to the
F by A.
perpendicular force. We just write the F perpendicular or we just write can thrust. So we write it as thrust per unit area. Thrust per unit
By
area.
area.
So we can also write it as the perpendicular force per unit area. The
Yes, sir.
perpendicular force acting per unit area is called as pressure. So
Sir,
why?
SI unit is Pascal.
Yeah, of course, its SI unit is Pascal. But why do we need to study pressure? Why we are not only focusing on force? Why we are going towards pressure?
Sir, because buoyancy.
No, not because of the buoyancy. Can anyone think of why we are looking for pressure and not only studying force? Why do we need to study pressure?
Sir, because gravitation is directly proportional to pressure.
Gravitation is directly proportional to pressure. No, see, why the reason? Why we are at the pressure? Why we need to know the pressure? The main reason is here that the effect of force. So I'll show you the example here. The effect of force. Sampath? Sampath?
Yes, sir.
So see, the effect of force is dependent on area. Why? How see? The effect of force. the same amount of force can cause different effects depending on the area on which it is acting. So, to study the dependence of force on area, we used the quantity pressure. Okay. So, how we have the force being dependent on area? Let's see.
So the
So,
more area, the
we
less the effect.
yeah.
The more the area, the less the effect of force, and the less the area, the more the effect of force.
Just 1 minute. We'll study this with an example. Why we go to memorize the things? Okay. Just see this. Okay, I'm taking a balloon for you, and I give you two tasks. So there are two balloons. I'm giving you some task over here. Okay. So, what do you think? How much of force do you need to explore this? Yes. How much force? A very small amount force, a very big force. What is the minimum force which we require here so that the balloon will just explode? Yes. Can anyone think of? Yes, can anyone think of what is the minimum amount of force that will be required to explode this balloon? Okay, let's try to answer it like this now. So, you press this balloon with your hands from both the sides. So you keep this balloon in between your hands. Okay. So you place it your one of the hands over here. You place the other hand over here, and then you start pressing it. So you will need to apply a larger amount of force. Then only the balloon will explode. Am I correct? Yes, you might have tried this in your birthdays or somewhere. Yes, am I correct for this one? That the balloon will explode only if there is a large amount of force.
Force exerted on it, sir.
Yes. Okay. Now, can I explode this balloon with a very small amount of force also?
No, sir.
What about a pin?
Yes, sir. Pin can because it has more surface area with the balloon.
Yes. So can I say that the effect of the force is depending on the area of contact?
Yes, sir.
Yes. The same balloon can be pricked off by a small pin with a small amount of force. But to explode the same balloon, you need a large amount of force if you press it with your hands. Okay. So here, if these are the two cases when I use my hands to press it, and the second one is I use a pin. So if I use a pin, here I observe that I need a small force. All right. For the same thing, for the same effect. And when I'm using my hands, I need here a large force or a big force. Right. Why the reason? The reason is hands have the large greater surface area. Am I correct?
Yes, sir.
Okay. So this will happen every time. Let's see some more examples. Hands have greater surface area. Okay. Now again, try walking on a pebbled road. Okay. So you have two types of road over here. You have a smooth flat road on which you are trying to walk like this. A smooth flat road. And you have another road which is pebbled. So let's say another road which is pebbled like this. So it's made up of pebbles of differently shaped pebbles have been laid down over here. Okay, so that the path has been made. So where do you think that it's easy to walk barefoot? In the first one or in the second case? Yes. In which case is it easy to walk? On this first one, on the leveled road or on the pebbled road? So if you are walking on a pebbled road, here you will
Well,
suffer more pains.
it is easier to walk on a smoother road
Yeah, it is easier to walk on a smoother
because
road.
our feet have a greater surface area with the road. But in a
Yes.
pebbled road, people require more force to be exerted by legs.
Yeah, the same force is being exerted by the legs, but due to the shapes of the pebbles, there will be a small amount of area of the feet which will remain in contact with it.
Yes,
Okay,
sir.
so the quantity which is showing you here, that the effect of the force is depending on the area, that quantity is pressure, and hence we can say that in one of the cases here, on the when you're walking on the level road, then here the pressure is less. Alright. Whereas if you are walking on the pebble road, here the pressure is high. The reason being that pressure is inversely proportional to area. Pressure inversely proportional to area, and pressure directly proportional to the thrust or the force. Got it? Okay. So, okay, what about pressure? Is it a vector quantity or a scalar quantity?
Sir, scalar.
So, pressure is a scalar quantity. It's not a vector quantity.
Sir,
Why
because it doesn't have direction, no?
it doesn't have direction? Or you can say when you pierce an iron nail through wood, so it exerts force in all the directions, in multiple directions. Okay. Hence, the pressure does not have a single direction, and therefore we can't count it as a vector. Okay. So pressure is a scalar quantity, and we look for its SI unit now. So SI unit of pressure,
Pascals.
yeah, is Pascal, represented by PA, which is Pascal. Or we can also call it to be equal to Newton per meter square.
Yes, sir.
So SI unit can also be Newton per meter square. There are different other units also for pressure. So what are the other units for measuring pressure? The other units which we can think of for measuring pressure, they are atmosphere, bar, you can say centimeter or of mercury, to centimeter or millimeter of mercury. So these are the different ways of measuring the pressure. You can either measure it in Pascal, you can measure it in atmosphere, you can measure it in bar, you can measure it in centimeter, millimeter, or mercury. Okay. So let us try to say here what is one atmosphere. Can anyone state what is one atmosphere?
Sir,
Yeah. Can anyone state what is one atmosphere? What is one atmosphere? See, one atmosphere, it is the pressure exerted by the Earth's atmosphere. Pressure exerted by the Earth's atmosphere at the sea level. So it is the pressure exerted by the Earth's atmosphere at the sea level. So at the sea level, the atmosphere, whatever pressure the atmosphere exerts, or the air around us exerts, that we call as the one atmosphere. And one atmosphere is roughly equal to, we write it one atmosphere to be roughly equal to 10 to the power 5 Pascal. Got it?
Yes, sir.
Remember, everything has to be in SI units. Okay. So we'll see some questions from NCRT again for pressure.
Yes, sir.
Mm. Okay, see this one. Try to solve this example. Just think of it. I'm giving you 2 minutes to think of it. Then I'll solve. Okay. Think before you solve. Okay. So see, the question clearly says that you have to find the pressure exerted by each block. So the pressure exerted by each block can be calculated by finding the force per unit area. So we find the force per unit area acting on the body, which will give us the pressure. So for this first block, for the first block, we'll see what is the force acted by it. So its mass is given as 5 kilogram. The mass of both the bodies is given to 5. So this is mass 5 kilogram. This is also a mass of 5 kilogram. We'll obtain for the case A first. So for the case A, the pressure will be given as pressure is for thrust per unit area. Now, as we know that this block is attracted towards the gravity with a force equal to its weight. So what is the force acting on the earth?
Sir, 5
How much?
5 kg
That is the mass.
mass.
So here the force will
So
be
force is
equal to
mg,
its,
mass into gravity.
yeah, force here that is being acted by this block on the surface of the earth will be just the weight of the body, which will be equal to its mass multiply acceleration due to gravity. So its mass
40,
is given as 5.
49. 49, 49.
Okay, 49. Let's take it to be, let's take the value of G as 10. So if you take the value of G as 10, you get here
50,
50
yeah,
Newton.
sir. Yeah.
So this is 50 Newton. Then we need to find the area of contact. So what is the area of contact here? See, the bottom surface which is in contact with the earth, it has the length equal to 20 centimeter and breadth has 10 centimeter.
So length into
Area,
200.
so this area can be calculated as 20 centimeter multiplied by 10 centimeter, but we will first convert it to SI
Into
system.
meters.
Yes. So
So
in SI
1
system,
meter is 100 centimeters. So 10 by 100 and 20 by 100.
yeah, 20 by 100 is 0.2 meter.
So and 0.1, which is
Okay.
10.
So it is 0.2 multiplied 0.1, that
So
you
it's
get 0.02 meter
2
square.
meters. So we get P as 50 by 0.02.
Okay, so pressure is 50 divided by 0.02. So
So
this
we
will
can
be
make 50 by
5000
5,000 by
divided by
2.
2. So this will be
2500.
2500 Pascal. Okay. Now similarly, obtain the pressure exerted by the block B.
So this time it's 0.4 into 0.1. So it will become 55,000 by 4. Right, sir?
Yes. So what's the answer?
So 5,000 by 4, 1 minute. 12,
Five-
5,000 by 4.
Okay, 1250.
Yeah, sir. 1,000 250 pascals.
Okay, so for this one, I get the pressure here. I can write my pressure will be equal to force per unit area. The force which is given here will be so see the force which is given here. The force will be given as mg again. So that will be 50 Newton divided by the area. Now the area is
0.04.
0.1 multiplied 0.4.
Say 0.04.
It is 50 divided by 0.04.
So which is 5,000 by 4, which is 1,250.
This is 5,000 divided by 4, which is 1,250
50 pascals.
Pascal. Got it?
Yes, sir.
Okay, we'll try on one more question.
Oh, sir, thrust and pressure, we also have buoyancy in this chapter.
Yes, you also have buoyancy. Okay. But today we'll do only
Thrust
pressure.
and pressure.
So next topic is, next question here. Is you see a girl of mass 40 45 kilogram wears heel sandals having area as having square shape with sides two centimeter. An elephant has mass. So an elephant has mass of 1,000 kilogram and its each feet has an area of each feet has an area of uh, uh, 225 centimeters square. Let's say 250. Okay, it has an area of 250 centimeters square or square centimeter. So it's 250 square centimeter. So your question is, who exerts let's say what is the pressure exerted by each of them on the ground? Okay. You also have to tell who exerts a greater pressure. So you can start solving. who exerts a greater pressure. So you can start solving. Okay. So try to solve this. Just take your time, solve this.
Sir,
Yes.
sides 2 centimeter, meaning the area like.
See, she's wearing a
See,
sandals
but
with
we
a,
have to convert 2 centimeters into meters, no?
yeah, everything it has to be in meters, meters per hour.
Okay.
Uh, okay, anyone has got the answer?
Sir, 1 minute.
Okay, okay. So let me see who all are present till now. We have Rohit, Sampark, Yukta, Likita. Yeah, Likita. Likita,
Yes, sir.
Likita, can you tell the answer if you got?
What, sir?
Can you tell the answer?
Yes, sir. 1 second.
Sir,
Yes.
for the first one, I got 11,000 to 25 Pascal.
And what is the pressure for the second one?
So I'm getting 0.0003637 Pascal.
Okay, just let me check it. What all values you get over here. So for the girl of mass 45 kilogram, we get its weight to be 450 and 450 divided by the area. So it would be for girl, we get pressure P will be equal to 4, that is 45 multiplied 10, which is the weight, and the area will be 0.02 times 0.02 times 2. Why I have taken times 2? Can you think why I have taken times 2 here? Because the girl has 2 feet. Okay, so area will be, this is the area of one of the feet, multiply by 2, that will be the area of 2 feet. So you get the answer as 450 divided by 0.08. That's the area. So converting it, you got 4,450 double zero divided by 8. So you can divide this by 8, 4500 by 8 to get the answer.
It becomes 1 minute.
It's 5,625 Pascal for the girl. And let's see what happens for the elephant.
Yes, sir.
So for the elephant, its mass is given as 10,000. So weight
10,000
will
is
be
98,000
10,000
Newton.
multiply 10, alright, divided by the area, which is this one is in square centimeters. We'll convert it to square meter. Let's see how we'll convert. So you have 250 multiplied by 4, as the elephant has the 4 legs, and convert it to converting square centimeter to square meter. You get here multiply 10 to the power minus 4. So this numerator you get as 10,000. This is 10,000 multiply 10 divided by 250 times 4 is 1,000. So you get 1,000. The three zeros cancel, and you get is 100 multiply 10 to the power 4. So you get 10 to the power 6 Pascal of the pressure exerted by this. So definitely the pressure exerted by the elephant is greater than the pressure exerted by the doll. Got it? Anyone who didn't find the solution or who didn't get the solution? Okay. Okay, so all right, we'll see you again in next class. Bye everyone. In the next class, we'll start with buoyancy. Next physics class, we'll have buoyancy.